Okay, number 15 asks about the continuity of a function. And it wants you to state any places where it's discontinuous and the kind to classify it. And it gives you a graph in case you want to graph or know what the graph would look like. Now, I'm going to tell you you don't need to graph it, but I'm going to graph it to show you how to graph a rational function because that's also something you need to know. So we'll talk about the continuity first. So when you look at a rational function right here, the top, my dog is snoring. The top is the zeros, and the bottom where if you set that equal to 0, where whatever makes the bottom 0, those would be your asymptotes, your vertical asymptotes. So I'm just kind of helping you out with this. So I already know that negative x squared is a continuous function and x minus 1 is a continuous function. But if I put one over the other, the problem with discontinuity becomes that I have a time on the bottom, a certain x that would make this undefined. So x minus 1, set that equal to 0. So at x equals 1, my function is going to be undefined. And that means you have a vertical asymptote at x equals 1. So if I were graphing that, I would draw in this vertical asymptote at x equals -1. Now I already know that I can't cross that vertical asymptote, so I have a discontinuity at x equals 1. So I'm going to say at x equals 1, I have, and we call that kind of discontinuity infinite. I can't even spell. So we'll say infinite discontinuity at x equals 1. Now we don't have any holes or anything like that. Holes are when you can simplify and cross out, like if you had an x over x minus 1. Those would cross out and you would have a hole at x equals 0. So you don't have that with this, so the only discontinuity would be that asymptote. So this would be the answer to the question. There's infinite discontinuity at x equals 1. Now, if we want to actually graph this function, there's several ways. We first would look for the vertical asymptote, and we have that. Then we would look for horizontal, and that's where you have those three conditions. If the degree on the bottom is bigger than the degree on the top, then you have y equals 0. If they're the same degree, you have a over b with the coefficients. This is a case where you don't have any horizontal asymptotes because the degree on the top is bigger than the degree on the bottom. But you do have something here that we talked about a little. You have slant asymptotes because the degree is one more on the top than on the bottom. And so if you do long division, you get the slant asymptote. So I'm going to do that real quick. I have negative x squared plus 0x plus 0. I'm just making sure when I do long division, I want all my terms. So then I divide that by x minus 1. So I get negative x. And so negative x would be a negative x squared and then plus x. So when I come down and I subtract this, I have 0 minus x. So I would have negative x and then bring plus zeros down. So that would give me minus 1, right? So this is going to be the equation of my slant asymptote. Y equals negative x minus 1, which would be this line right here. All right, I also know that I have zeros. So this is another thing you can get from the top. I have zeros at 0 because you would set the top equal to 0. So I have a point here, which you can safely say if the point is in there that this is how this graph would look. Sorry, it would be hugging that. It's going to hug this. It's going to get closer and closer to that, and then it's going to come around. It has to hug that. Now I might want to know, hey, what's going on down here? Am I on this side or that side or that side? But I'm pretty sure I'm going to be in here. But let's check. So let's try 2. If we put 2 into the original equation, we should get a point down here if it's in this area. So if I say x equals 2, then I have negative of 2 squared, which is negative 4, over 2 minus 1, which is 1. So I'm down at, sure enough, at that actual point. So I also have the graph like that. So that's the graph. There are no more discontinuities. You can see you just have the 1. And then I just showed you how to graph that function. Number 16 gives us an example of a piecewise function. Piecewise function, so many times they're jump. They can be. They're the easiest ones for jump. That means here I have a breakpoint at 5. All right, are they the same thing when you put 5 in? If they're not, if you put 5 in the one and 5 in the other and get something different, then you have jump discontinuity. You don't need to graph it. This is continuous. So from 5, before 5, you would have a very continuous function. You know exactly what that looks like. And after 5, you have a continuous function. So all you really need to know is what the heck is happening at this 5 when I switch from one, go from one function to the other. So at x equals 5, we have the first function would be f of x. It would be 4. And at the second one, f of x would be equal to, let's see, we've got to put 5 in, so 25 minus 40 plus 17. So 25 and 17 is 52. So we are definitely not at, did I do that right? Not 52, couldn't be. Hang on. Wrote this wrong. It's 17, not 27. So 17, which would give us 42. So we're at positive 2. So those are not the same. At 5, they don't equal the same thing. So you're going to have the function jumping from one to the other. So this function, the answer, is that you have jump discontinuity at x equals 5, because that's where everything's happening. So I'm going to just graph this really quick to show you the jump. So graphing x minus 1 is just this graph, and we want it going in this direction, and I go all the way to 5, right? 3, 4, 5. And so at 5, there's an open hole, because it says it's just at less than 5. All right here. Now, x squared minus 8x plus 17 at greater than or equal to. I have to graph this quadratic function, and that's why this is a good question, because I wanted you to remember how to graph it. So I have x squared minus 8x plus 17. So I'm going to say, I'm going to use the opposite of b over 2a to get the vertex. So that would be 8 over 2, or 4. So the first point would be 4. The vertex would be at 4. And then substituting 4 in to the function, I get 16 minus 32 plus 17. So that would be 1. So 4, 1 is the vertex. Okay, so at 4, 1, I have the vertex of this. And I really want to know, and at 5, we already decided, what was it at 5? It was 2. Oops, I did that wrong. It's 4, 1. So let me get this out. 4, 1. 5, 2. And so we can already tell that this is going to go up like this. And we have, at 5, we have this jump right here. This is a solid dot there, and we have a jump. And we don't really even need, because it's less than 5, sorry, it's not here. That was the vertex. Our point would start there. And it's solid. So there's your jump discontinuity right there.